When simplifying exponential expressions, you do need to know the exponential rules, and they keep coming up again and again and again in math as you progress. I've never found the names of the rules to matter as much as actually being able to use them. And also it's a matter of knowing which rules you can use in one step. You can't do too many things at once or you'll make some careless errors. So, an exponential expression is simplified just like a regular expression if it has no parentheses. So we need to have no parentheses. To clear parentheses, we have three basic rules. Exponents distribute over multiplication. A times b to the n is a to the n times b to the n. Exponents distribute over division. A over b to the n is a to the n over b to the n. Be very careful. Exponents are a shortcut for repeated multiplication, so you cannot distribute over addition or subtraction, only over multiplication or division. So exponents distribute over multiplication, exponents distribute over division, and when you have a power to a power, you multiply those exponents. So all three of those rules you can use together, and typically you do. We want to have only positive exponents. The average person will know what 5 squared means. The average person will not know what 5 raised to the negative 2 means. So we have two rules dealing with exponents that are not positive. Anything to the 0 is 1, as long as we don't try raising 0 to the 0. That's called an indeterminate form. You see it in calculus. And you learn how to handle it to get it into a different form there. But anything to the 0, as long as you're not raising 0 to the 0, is 1. Be careful with what the base is. That's where you'll make errors with this rule. And negative powers go to the reciprocal. So negative powers, you flip. We also want not to have the same base. If we have the same base, combine them. So for this, we have two rules. Same base with multiplication, you keep the base the same, and you add the powers. Same base with division, keep the base the same, and subtract the powers. These two rules will come up again when dealing with logarithms. Okay? So, exponential expression to be simplified, we can't have parentheses, we can only have positive exponents, and we don't want the same base. So these are the 7 main rules for getting started with exponential expressions, and you can only use one group of these in one step. So, what we're going to do is play with this example and do this example a couple of different ways. Okay? So, first way I'm going to do it is by clearing parentheses. Now, inside the parentheses, I only have multiplication and division. Exponents distribute over multiplication and over division, and when I do that distribution, I multiply my powers. So, this will be x to the 2 times negative 2, negative 4. X to the negative 4 times negative 2, x to the positive 8. X to the 3 times negative 2, x to the negative 6. Over x to the negative 7 times negative 2, positive 14, x to the 5 times negative 2, negative 10. Now, I've used all 3 of these rules in that step, and at the end of that step, no parentheses. What I'm going to do next is I'm going to say, okay, I want only positive exponents. So I'm going to take negative exponents and flip them around. X to the negative 4, well, I don't want a negative power, so it goes to the reciprocal. X to the positive 4, now in the denominator. X to the 8 stays just where it is, positive power. X to the negative 6, negative powers go to the reciprocal, so it'll be x to the positive 6 in the denominator. X to the 14th, positive power, stays where it is, x to the 14 in the denominator. X to the negative 10, negative powers go to the reciprocal, so x to the positive 10 now in the numerator. Here, well, I've taken care of step 2, only have positive exponents, but I do have the same base. Same base with multiplication, I add powers. So x to the 8th times x to the 10th is x to the 10 plus 8, x to the 18th. X to the 4th, x to the 6th, x to the 14th. 4 plus 6 is 10, 10 plus 14, 24. Now I've got the same base with division. Same base with division, subtract exponents. Now I could do this and say 18 minus 24 is negative 6, and then a negative 6 go to the reciprocal. If I think about if I were to write out what this means, I'd have 18 x's in the numerator, 24 x's in the denominator. I'm going to cancel out x by x, and each time I have that common factor, I'm going to divide out, leaving a 1 behind, but I'm going to end up with more x's in the denominator. So what I'm going to do, knowing that, I'm just going to go ahead and say I'll have a 1 in the numerator, and I'll have x to the 24 minus 18, 6 in the denominator. Notice 18 minus 24 is negative 6, which means put that in the denominator. Okay? We could also have started out this problem by saying, well, let me simplify what's within the parentheses first, because I've got the same base. Working within the parentheses, I might see, well, I've got the same base, so I've got x to the 2 plus negative 4 plus 3 over x to the negative 7 plus 5. This is all to the negative 2. Negative powers, same base multiplied, we add. So this gives me 2 plus negative 4 is negative 2. Negative 2 plus 3 is 1. Negative 7 plus 5 is negative 2. This is still to the negative 2. Same base with division, we subtract. So I'll have x to the 1 minus negative 2. This is still all raised to the negative 2. 1 minus negative 2 is 1 plus 2, which is 3, still raised to the negative 2. Power to a power, we multiply. 3 times negative 2, negative 6. Only positive exponents, negative powers go to the reciprocal. 1 over x to the 6th. Exact same answer as before. Which way should you use? The way that you see, the way that is more comfortable for you. Here I'll see people make fewer mistakes because they're not dealing with negative numbers and addition and subtraction. Either method is perfectly fine. As you progress, you'll use this more, but getting started, going ahead and turning all powers into positive exponents may be easier for you. I also could have done this by saying, well, inside parentheses I've got positives and negatives. Let me make those all positives. X squared, positive power, stay where it is. X to the negative 4, negative power, flip. X to the 4 in the denominator. X cubed, positive power, stay where you are. X to the negative 7, negative power, flip. X to the 7th in the numerator. X to the 5th, positive power, stay where you are. This is all to the negative 2. Well, same base with multiplication, I can add. X to the 2 plus 3 is 5. 5 plus 7 is 12. X to the 4, X to the 5th, 4 plus 5, X to the 9th. This is still to the negative 2. Same base with division, I subtract. I have more variables on the, or more bases on the numerator, so my answer is going to stay on the numerator. 12 minus 9 is 3, so I have x cubed. This is still all to the negative 2. Be very careful and do not ever drop any parts of your problem. Negative powers go to the reciprocal, so I'm going to flip this. This will be 1 over x cubed, and this is now squared, because I dealt with the negative power by going to the reciprocal. Exponents distribute over multiplication and division, so I'll have 1 squared over x to the 3 times 2, x to the 6th, 1 over x to the 6th. Same answer to this problem, multiple different approaches to the problem. We're just using these rules in a different order each time. And one way is not better than the other. Be careful that you are using, again, only one group of rules at a time. And spend a lot of time practicing exponential rules, because they will continue to come back.